before we start to talk about space complexity, I just want to say that if you want to support me and if you want me to continue making these free videos, please subscribe and turn on notifications so you don't miss any video. So let's talk about space complexity. Space complexity refers to the amount of extra memory your algorithm needs to run. This is important because in some cases, this is not just about how fast your algorithm runs, but also about how much memory it's going to use. Think about it like this. If your algorithm works fast but uses a huge amount of memory, it might cause issues when you run it on a system with limited resources. Space complexity is also expressed using big O notation, so you will not have a difficulty there because it is kind of similar topic as time complexity. So we can start looking at the common space complexities. So as I said, it is similar topic, so we will have the same notation, big O notation, O1. In time complexity, it's called constant time, but here it's called constant space. So that means the algorithm uses a fixed amount of extra space regardless of the input size. And the other time complexity notation is ON. That's called linear space. This is where the space used grows in proportion to the input size. A common example would be maybe creating a new array or list that is the same size as the input. And also we have O n log n and also O log n. And also, of course, O n square. So O n square is the same as O n square that we have checked in time complexity video. So it's quadratic space. O log n is logarithmic space, and O n log n is linear logarithmic space. We will talk about this later in coming videos, but if your algorithm creates two-dimensional array, or like maybe matrix size of n multiplied by n, so we can take an example of like a matrix size. Let's say that it has like a 3 by 3. So that means that if your input size increases by 10 times, the space that is required will increase by 100 times because it is O(n) squared. It's quadratic space. So don't worry if you don't understand these topics. You will understand more, you will learn more moving forward in the coming videos, because these time complexities and space complexities stuff is really best to learn by examples, and that you will have in the coming videos. And last point, sometimes we will have to make trade-offs between time and space. You might choose an algorithm that's slightly slower but lose much less memory.